Okay, welcome to video 5 here. We're going to be talking about graphing linear inequalities. So it's a lot like graphing lines, which we've already talked about and you've all been very good at. So now we just need to change it to being inequalities. So the first thing you need to do is determine the type of line that's going to be graphed. Either a hoi, so if it's y equals a number, vox, if it's x equals a number, or a diagonal line, y equals mx plus b. And remember, those include positive and negative slopes. Then you identify the slope and y-intercept just like if we were to graph a line by itself. We plot the points just like normal, but you do not connect them yet. You need to first determine the line type. So this is the new piece of information here. So we have different types of lines based on the inequalities. So if the equation has a less than or greater than sign, then you connect the points with a dotted or a dashed line. But if the equation has a less than or equal to or greater than or equal to sign, then you connect the points with a solid line. The next thing that we have to do that's a little bit different is determine the shading by picking a test point. And we mark that point with an X on the graph so we know where our test point is. Then we have to substitute the test point in the inequality, but you have to be very careful that you do not pick a point that is on the line, because when we talked about lines, any point that was on the line, remember, was a solution, and so if we plugged them in, it was equal on both sides. But here, we want to know if we need to shade above or below. If it's a dotted line, any point that is on the line will not be included. If it's a solid line, any point on the line will be included, but it won't help us know if we're going to shade above or below the line. So if the test point yields a true statement, then we're going to shade towards it. And if it doesn't, then we're going to shade away, or the opposite way, or the opposite side of the line. So remember that solutions on solid lines are in the solution region, which means that they are solutions. But points on dotted lines are not in the solution. So let's look at a couple of examples together. For my first example here, it's a y is less than 3. So first thing I notice is that it is a hoi, meaning horizontal line with a 0 slope, and it's written as y equals. That's how I knew that that was a horizontal line. So I'm going to start by plotting a point at the y value of 3, so that means I need to move up 3. So the easiest one to do is not move left or right at all, but just move up 3 spaces. But that's not a line, that's just one point on that line. So if you want to do a second point on the line, you can, and that just means find another point where the y value is 3. And then we can just connect them. But remember, we can't connect just yet. We have to first determine what type of line it is. Well, if I look, since it has just less than, not less than or equal to, that means that I have a dotted line. So I need to connect with the dotted line. Okay, so now we can see here that I've connected with the dotted line, and that was because it told me I had to worry about what type of line. But next, I need to do a test point. So I'm going to write out a test point. And the easiest test point to use is 0, 0, as long as it's not a point on the line. And it said that I need to mark that with an X, so I'm going to put a little X at the point 0, 0. So 0, 0, is it a solution? Well, if I plug 0 in place of my y value, since I don't have an x value to sub 0 and 4, I don't have to worry about that one. I get 0 is less than 3. And in this case, I don't have to worry about solving anything or combining anything. It's just 0 is less than 3. Is that true? Yes, it's true. So that means that I'm going to shade towards where 0, 0 is. So everywhere below this line is a part of the solution. And then I'm going to put an S here because we always mark our solution region with an S, saying that this is where all of my solutions live. And then the next part of this question said that we needed to graph the following, label the solution area with an S, which we just did, but also identify a point in the solution. So since my test point worked, I can say that one point in the solution is 0, 0. And that's it for that question. Okay, we'll do more of these tomorrow. Have a good night.